Think about the last application you built. Hundreds of libraries, maybe millions of lines of code. But the question is, how much of that code did you actually write? Today, we're talking about dependencies and the role they play in modern software development. Let's break it all down on this episode of Open Source Open Mic.
This is Open Source Open Mic, the podcast where we talk about everything happening in the world of open source security. So pull up a chair. It's time for an open conversation.
Hello, everyone, and welcome to another episode of Open Source Open Mic. My name is Andrew Garrett, and I am a product marketing manager here at Sonatype. And I'm pleased to be joined today by my guest, Eddie Knight. Eddie is a software and cloud engineer with a background in banking technology. When he isn't playing with his 3-year-old son, he combines his passion and job duties by working to improve the security of open source software. Eddie currently helps lead several security and compliance initiatives across the CNCF, OpenSSF, and Finos. Well, Eddie, it's great to have you on this episode today. Is there anything else you would like to add about your background?
Oh, absolutely. So here in Sonatype, we have a special role reporting to Brian. If you folks remember that Brian originally made Maven Central, was part of the team that made Maven before coming to found Sonatype. So he has always been deeply, deeply passionate about securing open source at the source as well as at the ingestion point, which is where Sonatype specializes. But I have been very lucky for the last couple of years to fill the role that is focused on actually going out to open source projects to help with security. So I've been part of the technical oversight committee for the financial technology open source ecosystem. I'm a security advisor for the CNCF, and I built the open source project security baseline, which is now a very highly adopted security standard used across the Linux Foundation, other open source ecosystems. The German government is using it. So it's really fun that Sonatype has been sponsoring me to do a lot of these things that are just helping every single project around the world make their software just a little bit more secure for end users. It's been really fun.
Yeah, that's amazing. And Eddie, I'm really glad that you carved out a few minutes of your time today to speak with me. And, the topic that we're going to touch on today is all about dependencies. We're calling it Dependencies 101. And we're going to talk about how much of your code did you actually write. So let's start right there. Open source has become so prevalent in the modern world. And I wanted to ask your opinion, how much of modern software is actually written by developers?
Oh, well, I mean, when the alternative is if it's written by an AI, I think the really interesting thing is how much of it is written by your team, right? I can't estimate how much is written by AI specifically, but we know that it's like 95%, sometimes higher of the code is dependencies that's written by somebody else that you've never met. Actually, okay, Ilka probably won't be upset with me talking about something that he's not publishing yet, but he has this amazing tool right now that it's kind of an R&D where he's taking all of our data from SBOMs. So he's taking one big like Spring Boot. He showed me this. He pulled up Spring Boot and he put it into a galaxy map where all the dependencies are not in just like a tree where they're like pointing to each other, right? But they're loaded out into this like big ball that has all the lines between it and stuff. But it's like three-dimensional, so it's like a freaking star map, but it's so big that he had to blow it out into clusters to where it's like, okay, these 12 are kind of related topically. These 12 are kind of frequently used by those, but it's just this massive blob of clusters of dozens, and it's just all over the place. And then you have the lines that you can kind of follow between it. And then he starts color coding it to show you which ones have vulnerabilities. If you find one malware in there, it's super surprising, but it's like a big deal. But it's massive, right? He says, okay, now look what happens when I switch it to a tree, because a lot of us like to think of our dependencies as a tree, right? I import your software, you import Bob's software, but Bob might import Stacy's software and I import Stacy's software. So it starts getting really wonky. So he says, look what happens when it turns into a tree, right? And it becomes this like smushed thing that doesn't even fit on the screen anymore. It's just horizontally, just massively wide. It's maybe 5 or 6 layers deep, but it's 1,000 wide, right? And that's just because the way that we write software, especially in modern languages, is just you stand on the shoulders of giants. You import other code that works because it does it well. You don't need to repeat it, but your dependency space is just massive, absolutely massive.
Hmm. Yeah, I'm glad you bring that up because, yeah, 90%, 95% of all software, we hear this percentage often, 90 to 95% is open source. And I like what you said, standing on the shoulders of giants. And, I wanted to bring up the point of dependencies specifically. But when we talk about how much open source is out there and the way that code is written today, can you break down what exactly is a software dependency? What does that mean?
Yeah. So if you're writing software, then this is old hat for you. But if you're managing software teams, then it is still important for you to understand that, um, like like the code that your teams are writing is going to have a list of imports that comes from somebody else, and they're going to have a list of imports, right? And so we call these the first ones that we choose, we call those direct dependencies, and then the ones that our choices chose, we call those transitive dependencies. But any software that we import from outside is our software dependencies.
Okay. Yeah, that makes sense. So, why would you say developers rely so heavily on dependencies today?
Because giants step on us, but standing on the shoulders of giants lets you be above all of it, right? There's no reason to be writing all of that code yourself.
Yeah. Yeah, I like that. So, uh, speed comes into play.
Yep.
Developers are able to just write code faster. They're not trying to reinvent the wheel or build something from scratch. Um,
There's
would you
also
say,
security. Security is a huge thing.
yeah,
There's actually a some guidance that we have, which is like we call it "Don't roll your own crypto." Right? You need to do cryptography, but you do not know how to do cryptography. Like, there's probably 5 people that I'm ever gonna meet that actually understand how to do cryptography and do it well. You should not be trying to do the thing that those 5 people have already done and made available to you.
yeah, yeah, no, that makes total sense. Um, so let's dive into that a little bit more. When thinking about the dependencies that teams are actually using, since they're not an expert in everything, right? To your point, is it challenging sometimes for organizations to actually understand what dependencies they're using?
Oh, yeah. I mean, the more that we bring in like modern supply chain tooling, it gets easier. But even with things like GitHub's Dependabot that are out there, you're not like getting a really good view. Like that star map that I told you that Ilka showed me, like that just
Hmm.
changed my mind. I was just like, that is a game changer. I hope that he can put that in a video somewhere that everybody can see very, very soon. But it's just there's so many dependencies in a single application, especially, I mean, direct and transitive and multiple layers deep. It's just so huge that when you start putting them into an SBOM, you get a little bit more machine readable visibility where your machines can start to know about them. But mapping them, graphing them, things like that, it's a massive undertaking.
Yeah. Yeah, we hear the term dependency trees, just sprawling out like you're describing. Um, Another term that is a new term for me is a polyglot environment. Does that mean anything to you? What is that? What exactly is that?
Yeah, well, I mean, polyglot is multiple languages, right?
Mhm.
Um, uh, it's not uncommon now to have kind of your back end and your front end in a monorepo, compile and ship your code together. In some cases, you're able to just do it all with TypeScript, but yeah, once you start having an environment that has multiple different languages in it, then you have multiple different mechanisms for tracking those dependencies in each of those. Some languages do like locking, some of them do like vendor style packaging. There's a lot of different ways in every ecosystem to do it. There's some patterns, so we can build tools on top of these things that kind of follow the different patterns. But every different language ecosystem manages its dependencies differently.
Okay. So, going back to my earlier question about organizations understanding what they're using, what you're describing, it sounds like this would be really hard if I am the dev lead or I'm managing a team of developers. Our dependency tree is just sprawling out. It sounds like the security risk would be just exponential at this point. The larger your dependency tree grows, I mean, is that really hard to secure something like that when you don't even know sometimes some of the things you're pulling in?
Yeah, and there was a point in time when Sonatype was the only vendor dealing with this, and we used to have to teach people about this. Like, hey, there's more happening than you can see. That this is beyond a tip of an iceberg situation. This is like a boat on the ocean kind of situation. There's just miles and miles of black water beneath you, and you have no idea what's down there. But nowadays there's an entire ecosystem around it, and I think most folks are starting to understand that at least they are in a dangerous situation, right? Like they are sailing in a ship, and if this ship goes down, they're in a bad spot. But without that, without proper like good tooling, good visibility, um, I I I hope that you have a big team and a small software footprint.
Yeah, I like that. Well, let's stay on your analogy here of a boat on the ocean because if you're this boat on the open source ocean, let's call it, there are several hazards or icebergs, if you want to call them, that you can run into. Vulnerabilities, malicious packages, abandoned projects. How do you go about navigating those challenges?
Yeah, I mean, I keep coming back to like you have to have software to help you with this, right? And that's where you start getting into like your job really is in triaging this, right? So once you have tooling in place that tells you, hey, here's a vulnerability, here's some malware, um, hopefully you have software that can tell you when there's abandoned software, um, or bad patterns, things like that, but you're starting to get into pretty complex software at that point. But what happens is like what do you do once you get those alerts? That's where you're back in control again. Like trying to do it without software, like you're in a bad way.
Yeah. Yeah, and I just think about recently some of the headlines we've seen coming through the security news lately. There have been a lot of large scale cyber attacks over the last few months, and we're recording this in early 2026. Uh, but as I think back on some of these large scale breaches, every time one of these breaches comes across my feed and I read about it, I always just think to myself, don't haven't they learned like haven't these organizations learned by now? Don't they have the security measures in place? So I guess my question to you is, how does this keep happening? How do we keep seeing these open source breaches even when we have so many security teams and we have projects like OWASP, the OWASP top 10, we have so many like warning signals, I guess, best practices, advice, so many things out there. How is it that this keeps happening so often? And it seems like the trend is frankly getting worse.
Yeah, well, I mean, AI is not making any part of security easier. Like it's the more you use AI, the more likely you're to have a breach. And I use AI. I'm not saying don't use it. I'm just saying you've got a different set of problems now.
Yeah.
But so some of the big open source breaches would be like so there's a few examples, right? So non-malicious log4shell, right? It was a vulnerability that was detected later on, and it's found to be like, okay, that's a big deal. We need to patch it, right? Um, that that was a Christmas surprise a few years back. Big deal. Um, then a couple years ago, we have the XZ Utils, right? Um, and there was a really good video by was it Veritasium that did a video on Jatan on XZ Utils, and it breaks down like how complicated this attack was. But it was all social engineering. And then after 2 years of social engineering, it became a technical attack to where it was like, okay, cool. How do we get this across the finish line? And then how do we hide it, right? How do we get our attack in there? And then how do we keep it from being detected? And the interesting thing is that it was detected by the obfuscation. The obfuscation slowed down the code, and one person was able to find it, uh, barely in time. Uh, which then creates the question that is kind of at the heart of this is like, well, how many other times has that succeeded if we only found it this once? But that was
Right.
social engineering was the big front there. It was a 2 year social engineering attack, not by one person. There is one persona and then a series of supplemental personas that hounded the maintainer until the maintainer was exhausted, and the uh, the primary persona stepped in and was like, "Hey, I got it from here.
Hmm.
Don't worry, man. We're in this together, right?" Yeah, we the theory is that there is anywhere from 3 to 12 people on that one account, making sure that that account was like really doing good work for those 2 years. Um, so that's so first one, vulnerability happens, you need to patch. Second one, we need to detect it and then patch it. Second one was social engineering. And then the third one is a the very recent one, this trivia attack. There's two trivia attacks recently. The one that I'm thinking of right now for the to continue this little narrative is the it was a exploit of GitHub. And so this is actually a core ecosystem utility that we all rely on, right? It's like GitHub is like the electric company for a lot of us, right? There's a couple electric companies depending on where you live in the world. You could kind of pick up your entire business and move somewhere else to have a different electric company. Same thing with GitHub, right? Like once you're on GitHub, you're on GitHub. Um, the interesting thing is that there's a particular vulnerability in GitHub that GitHub refused to patch. They called it a feature. Just like that, we're not fixing that, right? And it manifests in two ways, and we've known this for a really long time. GitHub's known it. I don't know which humans at GitHub have known it, but it's like logged in their systems for a very long time. Two ways that it can be exploited. One is through malicious attachments. So what'll happen is I trust the Andrew Garrett on GitHub, and I know that you only produce software that I love, right? Good software. I love you. You send me something, totally trust it, run it without asking, right? Then somebody comes to me and says, "Hey, look at this new thing, this new package from Andrew Garrett, right?" And I look at the URL and it says github.com/Andrew Garrett/ something download path, right? I'm like, cool, let me download that. Turns out somebody else went to your GitHub repo, left a comment on that GitHub repo with an attachment. That
Hmm.
attachment's URL is now Andrew Garrett. And you cannot do anything about that. You cannot delete that. You can't unattribute that download link. That download was uploaded in your namespace. and it is there. That link is solid. You would have to take that and like go through some GitHub support channels, right? If I and I'm this one I might be teasing the lines a little bit, but I think even if that person uploaded it and then deleted the comment, the upload's still there and it still has your name in the path. You
Mm.
might not have
Wow.
even known that it was uploaded under there to go through the rigmarole of trying to get it taken down. Um, so that's a very specific attack path. Like it's involving a download. You need to know the target's operating system, things like that. It's not been widely used as an attack path. So as people have been reporting it, there's not like a lot of use cases where it's like, and this is how it ended the world. It's like that hasn't really happened, right?
Yeah.
The second thing, same problem, is GitHub's um, branches, right? So we can have your GitHub Andrew Garrett, and I can make a pull request to your main branch on your repo, right? Well, all of my commits that used to be mine, they used to be Eddie Knight slash whatever Shaw commit, right? As soon as I open up a pull request, it's duplicated. So now I've got commits on mine, and I have those commits in your space as a pull request branch.
Mm.
So now I can put anything into your namespace, including operational code, right? So
Wow.
what somebody did was they went to Trivy, which is a security tool that loads of people use. Hundreds of thousands of people use it, minimum. I think when the exploit went out, it was something like 240,000 people just like downloaded it right away. Um,
Wow.
so what happened was somebody went on to Trivy and they said, "Hey, the official GitHub Actions repo has an update. Here's the SHA." And Trivy was just like, "Yeah, whatever." And they merged it in. The
Mm.
path was GitHub/GitHub. Like, why would you not trust that? It's like the official GitHub thing. Well, if, and here's the wild part, because I know that that's an exploit, um, when somebody showed that to me, I was traveling at the time, so I didn't see it till like 3 days later. So I knew it was an exploit. And they're like, here's the PR from the exploit. And I look and I was like, let me go to that Shaw. And I go over there, and there's just a super obvious I am stealing your code. Like, it's the most obvious thing in the world. And it was on a closed PR. Like, the GitHub staff just were like, they looked at that and they're like, no, why would we merge that in? Close the PR, moved on with their lives. But they weren't attacking GitHub. They were using GitHub's namespace to attack Trivy.
Mm.
And by extension, everybody who used Trivy had all their secrets exfiltrated as soon as they updated Trivy. Or as
Mm.
soon as they ran Trivy. It was very fast.
Yeah. So this sounds like social engineering at its finest.
Yeah, so I guess it was kind of a combination of social engineering. Like, I know that you trust GitHub,
Yeah.
right? But it's also a system exploit, right? So that's where I was kind of showing like different types of exploits here. This one is like, that there's a vulnerability in GitHub that GitHub hasn't patched. You know that this person you want to attack is using GitHub, and so you go through the tooling. Uh, so
Hmm.
so this is just kind of trying to elucidate on the complexity of open source. It's this just massive surface area. There's so many different ways to attack it, so many different
Yeah.
ways to social engineer, so many different tools that you can attack along the pipeline. Um, Hundreds of thousands of packages to social engineer to get up to one. And that's what happened with XZ Utils, right? The goal wasn't to compromise XZ Utils. The goal was to compromise the Linux kernel. And they almost did.
Hmm.
It got into a release candidate. Like,
Wow.
really big deal.
So, we hear all the time this phrase, trust but verify.
Yeah.
Trust but verify. How do you verify in a situation like that? What can you do?
Well, in the last example I gave, and everybody should be doing this now. If somebody who's not on your core team recommends an upgrade, pins are not enough. We usually say like use pins, SHAWs. You have to like if somebody you don't know recommends a SHAW, either just reject it or go check it. So that's like actually going into the URL, swapping it out. That's kind of complicated. Um, but I mean, for end users, right? For people who are not open source maintainers, who aren't taking pull requests from the internet, um, software. Just have software that can check these things, right? Because I forget if it was the first or second trivia attack, but all of the Sonatype users that had firewall, it stops bad downloads, right? Firewall has, before AI was AI and we were still just calling it machine learning, it's been doing its thing. It hyper optimized on certain signals, detected the trivia attack in 1 minute. And
Hmm.
so anybody who, I guess for the first minute we weren't helping, but after 60 seconds, any of our users were the life cycle was aware, stopped any incoming downloads, and were protected, right? And it's just use the right tools. Use the tools for the job that you're trying to achieve. If you're trying to protect your open source, have some SCA, have a internal registry, have some tools that can actually prevent things from getting to your registry if they're known malicious, have scans in place on the things in the registry and the dependencies that you're using with your end users. It's all about just have the right tools.
Hmm.
Then once you have the right tools, what's back in your power is what do you do when they alert? What do they do? What do you do once they send up a signal? That's back in your power again.
Hmm. Well, I'm glad you brought that up because that leads me into my next question about having good dependency hygiene. So obviously you touched on having the right tools. You need to have the right tools, and then you need to know what to do when an alert comes in. Is there anything else that you could recommend as a best practice to maintain good dependency hygiene? What does that look like?
Ooh, good dependency hygiene. Um, when I hear that, and you might need to lead the witness here a bit. When I hear good dependency hygiene, I think of like minimizing that surface area, right? Only use dependencies that you need. Don't use two of the same thing if you don't need to, right? There's like in Go, there's like my AI will always recommend a different YAML parser, right? I use a lot of YAML. And it's just always like it's just recommending a different one all the time. Um, I'll be in one file using one YAML parser and get to another file and it's like use a different YAML parser. I think there's three to choose from, but it also recommends outdated ones, right? So just like keeping an eye on that
Hmm.
you're using only dependencies that you need. Um, and then uh, because you're already keeping it tight, double check that you know that dependency. Like, do I know that author? Like, does it at least look clean, right? Is there some age on the account or is it from an organization that I trust? Things like that. And then from there you can rely on your tools for the rest. But like just kind of a sniff test up front will go a long way.
Yeah. Yeah, and if I could lead the witness here a little bit, I think automation is a huge part as well. And you've touched on this a little bit already, but you know, don't leave it all up to you as the end user. You take some of that out of your hands. If you can have some automated policies, things that just address the concerns before they even reach you, right?
Yeah. Yeah.
Yeah. Well,
Have the
awesome.
right
Well,
tools. You have to have the right tools.
yeah, absolutely.
Yeah.
Well, Eddie, this has been great talking about dependencies with you today. I've learned a lot, and I did want to wrap up our episode with a little bit of something I like to call the rapid fire round.
Uh-oh.
So this is where I ask you a question. You have to answer in 10 words or less.
Oh,
Yeah.
okay.
Okay. So let's do it. So, Eddie, in your opinion, what is the biggest myth about open source dependencies?
I think there's like the myth is that they're either completely trustworthy or completely untrustworthy.
Hmm.
I think that people tend to shift between the two of like, oh, like we can't trust open source versus like, oh, with many eyes, all bugs are shallow. We're good, guys. It's like it's somewhere in the middle. You need to be, we need your eyes too. We need you to come over and actually take a look. So that way the bugs are
Hmm.
shallow.
Okay. I like that. It's either completely trustworthy or completely untrustworthy. It's either black or white. That's that's the biggest myth in your opinion.
When put on the spot, yeah.
Fair enough. Um, well, next question. What is the most common dependency mistake that developers make?
Not thinking about dependencies.
Okay. What is the most underrated supply chain risk?
Yeah, the security of your source forge.
Hmm.
That is
Okay.
the most underrated risk, I think.
Okay. What is one dependency that every developer has used?
Requests.
All right. And then to finish up here with our rapid fire round, what is one habit every dev team should adopt tomorrow?
Spend more time reviewing code.
I like it. I like it. Well, Eddie, this has been great talking with you today. Really enjoyed the discussion. Really enjoyed your setup as well. You've got the great mic, you got the nice backdrop. You've been the perfect guest for this. So
No, this
uh,
is very fun. Very fun, Andrew. Thanks for having me on.
absolutely, yeah. And to our viewers today, thank you so much for listening. And if you're watching on YouTube, please remember to subscribe to our channel. And if you have a question for Eddie, please leave a question down below in the comment section. And we hope you enjoyed our episode of Open Source Open Mic. We'll see you next time. Thanks, everybody.